vaccine was already created in the laboratory. There was a patent on it already in 2003 by the Canadian Public Health Agency. So developing a vaccine in the laboratory is not the most difficult step. What is the hardest thing to do is to test a new product, whether it be a vaccine or some other medication, in human beings. So here in Geneva, we tested the vaccine on healthy volunteers, and we looked at it for safety, and we looked at it for immunogenicity, or the ability to trigger the production of antibodies in the blood of those who have received the vaccine. Indeed, there have been challenges identified during the production of and the testing of this VSV-Ebola vaccine. What we did expect, and certainly did find, was some initial reactogenicity. That's what we call those first flu-like symptoms that you get when you've got a new infection. And we did see that in some of our volunteers, not all of them, but these were very transient, didn't last more than a day. So not a big problem. What we didn't expect, however, was an actual dissemination, so a diffusion of the vaccine virus beyond the blood compartment. So we found a couple of weeks even after vaccination, we found in rare cases evidence of the vaccine virus in peripheral tissues such as the joints, the skin. So in these cases, all of which were self-limited, we did see vaccine virus going beyond the blood compartment and not being eliminated very quickly, as we had in most people. So what we've just discovered is what we call the signature of the vaccine in the plasma, so in the blood compartment of our volunteers. So what we did just before vaccination and in the days following vaccination, we looked at many inflammatory markers. So these are proteins in the blood that all of us have. We measured them both before and after vaccination, and what we consistently found was a spike, an increase in 6 of these inflammatory markers on the day after vaccination. So this signature that we found in the plasma, or the blood compartment, is really just the beginning. We actually believe that most of the activity that takes place just after injection of the vaccine doesn't occur in the blood. There we're just seeing spillover. What's happening is probably very local, right in the tissue where we've been injected with this vaccine. And there we are lucky to be working with a very large international group of researchers who are looking at differential gene expression, proteomics, transcriptomics, in other words, very particular effects of the vaccine, both in the blood compartment but also in tissues. And there we'll be able to, with that work, we'll be able to refine the signature of the VSV-Ebola vaccine much more in order to help better understand how this vaccine is going to work and how other vaccines will work.